Amazing.
Yeah, yes. Hi, everyone. Yeah, thank you for coming. Like Aleo and AKINDO Privacy Buildathon onboarding and kickoff event. And yeah, today, so we invited Alex from Aleo team. So today's, a workshop. So reading by the Alex. Hi, Alex. Thanks for coming this onboarding event.
Kinja, yeah, appreciate it. Thank you. Welcome in,
Yeah.
everyone. Um, my name is Alex. I'm the developer relations lead at Aleo, and this is the kickoff and onboarding sort of workshop and an event for our partnership with AKINDO, which is our building privacy-focused applications on privacy build fund. Is my camera still working, Kinja? I think my
Yes.
okay, amazing.
Yeah, it's no problem.
Okay, so let's kind of jump right in here and get started. So I kind of want to take a step back and look at the macro before I go into who we are and what we do. So why privacy? Why did we choose to make this our main focus for Aleo? And really, why privacy now? So privacy is essential for any real world use case in Web3, but also beyond that in Web2 and any traditional computing. If you think about, like, for example, finance, I mean, it's pretty easy to imagine why you need privacy, because you don't want your payment information being leaked. You don't want your bank account being leaked on chain. It's less obvious for things like machine learning, where the biggest thing out there right now are LLMs, ChatGPT, Gemini, so on and so forth. They require a massive amount of data to train on and generate these insights. That's kind of at odds with what the users want, where we want to protect our data. We don't want to give this. We want to minimize the amount of data we give to the social media companies and Google and all that. But it with this kind of LLM revolution, where these two things have been at odds. So how do we, as users, now choose to make our data private and only selectively disclose certain things? So I kind of want to jump to a tangible example here. So, for those maybe not familiar, back in the 90s, HTTP was the kind of the standard for internet traffic. Things were either walled gardens like AOL, where you couldn't connect to anything outside of the AOL ecosystem, or if it did any interoperability, it was totally transparent. So everything was sent in plain text. Like you couldn't do anything really with sensitive data like finance. You couldn't pay with a credit card over the internet, because you would just leak all your credit card details on anyone snooping on your internet traffic. Then around 1994, thanks to Netscape, they invented HTTPS, which is essentially encrypted HTTP traffic, and it solved like this explosion of e-commerce. So now you could pay over the internet with a credit card. You could do any kind of financial transactions, and then it kind of just um, exploded into this, all these huge market cap companies, um, and essentially unlocked the e-commerce industry. Web3 is here. We are kind of at our HTTPS moment, where crypto for the longest time has been this theory, this great idea that we're gonna totally overhaul the financial system, but has never really, the results have never been there to show that. We believe that privacy was the reason why, because all chains, other than at least that I'm familiar with, reveal all your information publicly on chain. So there is no notion of privacy. Any transactions you do, executions, um, sending back and forth, all the addresses and amounts and everything, you can go snoop on chain and on the Explorer and see what's going on. And there are companies like multi-billion-dollar companies like Chainalysis, who their entire business model is doing this, is generating these insights and monitoring your financial transactions. So just to hammer home why privacy, A16Z came out with an article at the beginning of this year saying the top things that they're excited for in crypto, this year and moving forward. So in most important thing, privacy will be the most important moat in crypto this year. That's as big of an endorsement you can get. Vitalik has said today privacy can no longer be ignored. He and the Ethereum Foundation are making big emphasis on privacy. I don't know if you've seen their Kohaku wallet. I think everyone's starting to finally realize that for real world adoption and big institutional players coming on, you can't not have privacy. And if you want market validation of that, see the price of Zcash over the past 6 months, 1 year, 5 years. So, again, why privacy in crypto? Let's say you pay with, let's say that stable coins are the new kind of wave, and you can pay with stable coins anywhere. If you go to pay with stable coins at like a coffee shop, for example, as they are now, you'll end up revealing your address and consequently all of your holdings to anyone along that process, including the baristas who check you out, the owners of the restaurant who are dealing with the finance, and it also ends up attributing location data to your account, because if you can find out that this is the address of the coffee shop's bank account, then you can track all the addresses that pay it and make a reasonable assumption that whoever's paying it is probably going to that coffee shop and lives in that area. So it's a total break in the user journey, and it's a non-starter for most use cases. On-chain payroll. If you're getting your salary paid in crypto, you don't want your coworkers to see what you're making, and you don't want to see, your boss doesn't want them to see what they're making, and you don't want to leak that to the entire world, because that makes no sense. And if you're thinking about from an institution level, businesses end up showing their finances and all their expenditures to their competitors. So that again, from what we understand, and this has been validated through our conversations, this is a non-starter for integrating these crypto rails into enterprise use cases. So they need privacy. So with that being said, sorry, a little less dramatic than I wanted it to be, but who are we? We are Aleo, and we are addressing this issue, and this chart I think will help hammer home that difference. So let's think of this axis, this graph here. On one axis you have privacy, and on one axis you have programmability. The first kind of crypto was Bitcoin, obviously, and it is pretty rudimentary by design. It's meant to be more of a store of value, and it is this idea of public money. So it is not very private and doesn't have any programmability. You can't really do any kind of complex DeFi without kind of significant engineering efforts. Obviously, people like Vitalik and the Ethereum Foundation saw this, and it says, okay, what if we could take this great idea of cryptocurrency and a blockchain and add this arbitrary programmability on top of it? And that's obviously where Ethereum came. So then we not only had public money, we had public applications, but we were kind of, still were lacking that privacy element. In tandem, or at the same time, we saw the development of Zcash. So Zcash wanted to take the idea of Bitcoin, this, public store of value and decentralized and all that, and add privacy on top of it. And Zcash became this private money, private store of value. So the thesis was, can we have the best of both worlds? Can we have all the great privacy features that Zcash helped pioneer, as well as the arbitrary programmability and expressivity that Ethereum pioneered? And that's who Aleo is. So we essentially enable programmable privacy on chain. And, for most of you who don't know, here's a little piece of lore that Aleo was actually developed by some of the same minds as Zcash. So some of the core researchers that came up with Zcash, Ian Myers, Matt Green, were also behind Aleo. So Aleo is a layer 1 blockchain with privacy as a first-class citizen and powered by zero-knowledge proofs. So our entire focus for our network is enabling privacy, but not only just privacy, programmable privacy. So you as the developer can choose to disclose certain information at the time, depending on how you implement in your function. And so the power goes entirely into the developer's hands and into the user's hands on what gets revealed and what doesn't. And just to, again, hammer home who we are, we have a lot of great partners. You may have heard of some of them: Coinbase, Binance, Request Finance, Revolut, the Global Dollar Network, and many more. What kind of products are building on Aleo? Well, we're very excited. We announced this a few months ago, but it's finally coming to fruition. We're bringing the first private stablecoins to the world. So we partner with both Circle and Paxos. So Circle will be launching USDCX, which is part of their X Reserve program. Aleo is one of the only 3 blockchains to be selected as the first members of this X Reserve program. And Paxos Labs is bringing the USAD private stablecoin to the network. And we anticipate these launching within the next few weeks. So it should be, we're hoping this will be ready by the time so you guys can get this into your hands. Kinja, I believe your mic's still on.
Sorry?
Your mic is on.
Sorry.
Amazing. So, and one last kind of exciting thing we want to share with you, and it's been coming along, coming to fruition, is we are also launching, or rather Provable, which is our labs company, is launching the Shield wallet alongside in the coming weeks. And this is kind of a brand new wallet experience where privacy is a first-class citizen. So you'll have private transactions, asset shielding, kind of accelerated synchronization, and this idea of delegated ZK proving. I'll get into that in a little bit. But yeah, so you can essentially, privately transact seamlessly with 0 transaction fees via built-in fee master. And most importantly, I think for you guys as developers, is they'll be able to ship alongside this JavaScript TypeScript adapter, so you can day one seamlessly integrated it into your front end apps. And I should mention that both a browser extension and a mobile app for both iOS and Android are in development. So last thing I'll say is, if you'd like to get early access, please scan the QR code and you can kind of sign up for this interest form, and we're happy to give you keep you updated as soon as things go live. Okay, so that was kind of my obligatory shill, but let's I'm gonna do a kind of a technical deep dive now into how Aleo works. So this is the Aleo stack, and I'll kind of go through it. At the top, we have our high-level syntax that our programming language is called Leo. It's kind of its own little unique language, but it's designed to be pretty familiar syntactically. And I'll go through a kind of a introductory in the coming slides. But yeah, Leo is our high-level language. It's kind of designed to abstract away all that ZK cryptography. So some of you may have played around with languages like Noir and other kind of privacy-focused or ZK-focused languages. They tend to be pretty granular and get into the weeds of like dealing with circuits and proofs. And Leo is designed, again, to abstract all that away and make it feel like you're programming something like TypeScript or Rust. That high-level language gets compiled down to this idea called Aleo instructions. Very kind of an assembly-like language with opcodes. You can think of EVM opcodes and things like that. Very similar idea. Those Aleo instructions are actually what gets broadcast or gets executed locally, and then also gets broadcast and put on chain. And the execution engine for running those is called Snark VM, and that kind of handles all that stuff, especially down to the interacting with the foundational ZK circuits. And Snark OS is the networking client and node that syncs up with the blockchain and deals with all of that. So that's kind of the high level overview of the Aleo stack. So let me kind of give you a high level overview of how this all plays together. So normally again, with any other blockchain, you would have to essentially, you as the user, if you want to execute your contract, you write it up, you deploy it on chain, and anytime you want to execute a function, you just, get whatever inputs you want and send it off, and then everything gets run decentralized on chain. In order to have this idea of privacy, we've kind of designed this new paradigm of splitting the off-chain and on-chain worlds. So in the off-chain world, again, locally, you essentially will have this off-chain VM, this virtual machine, this execution engine. You can think of this like the Snark VM I mentioned earlier. You'll provide it some inputs. Here we differentiate between things denoted as private and things denoted as public. In practice, like locally, it will still execute accordingly, like just if they're all plain text, but these kind of private and public markers will be useful once they actually get broadcast later, because private will be encrypted and the public will obviously be not encrypted. So the idea is that you as the developer get to choose what gets revealed for maybe compliance purposes, and if you want essentially certain aspects of user data like the address or sensitive info to be encrypted on chain, then you can mark it as private. So you provide these inputs to the off-chain VM. It does whatever computation, at least whatever part of the computation you want to keep private. Then you get the private outputs and the public outputs, again, just marking which ones you want to reveal and which ones you don't. And in addition, you may be able to specify alongside the public outputs these things called futures, which are any on-chain code you want to run, like as in a normal blockchain, functions and things like that. You want to access this on-chain storage or something like that. Here's where it would come alongside these public outputs and be run at a later time. The key difference here is we also output this idea of this pi, the ZK proof of execution. And that's how we make sure that like people can verify that this off-chain execution was done correctly and with, without kind of, making up information or trying to falsify things, while still keeping those inputs and outputs encrypted. So people can still verify that everything was done honestly without necessarily needing to know exactly what the specific inputs and outputs were. So once you have this execution and this proof of execution, we'll go to this on-chain VM, which is obviously running on the blockchain and decentralized and all that. And we'll send the futures and the ZK proof to this on-chain VM. And the on-chain VM will check that all these inputs that you ran, this computation that you ran, verify the proof that this computation was correct, and then take those futures and then execute this on-chain code, optionally accessing some kind of on-chain data, whatever you've stored there, and then reading and writing to and from it. So in practice, this is a screenshot from our block explorer. You can kind of see this is what the information would look like. So credits.aleo is kind of our default program, or it's kind of the core program that handles a lot of store value. We can see the function name is transfer public to private. So you're converting public funds to private funds. The recipient is going to be this, obviously an address you want to keep private. So it ends up just being this ciphertext that No one but the end users can decrypt. The public part is how much you want to send them, and it obviously has to be public because you're transferring public funds, some amount. And then the outputs are possibly some encrypted outputs, which again, this is a record, and you can't gather anything from it. And this block here is this future. So this is the on-chain code that gets updated. And this address here is not the same as this. This is the sender, and this is the recipient. So again, separating this idea in your head of having both this public-private duality and needing to manage it via off-chain, on-chain, two different worlds that are connected via specific mechanisms. So let's dive into that a little bit more. So this idea of private state are these things we like to call records, and they are these, essentially individual pieces of data. If you're familiar with the concept in Bitcoin of the UTXOs, this is very similar, where each record you can kind of think as a UTXO that also includes optional data, depending on what kind of program you're running. And every record needs to, at minimum, have this field of owner, because you need to know, obviously, who owns this piece of this data. And optionally, you can have an arbitrary number of types and fields in there. In this case, it just has a balance with some value attached to it. So the way records are used is they are, once you have a certain set of records, you can kind of think of this as like, with these tokens, like I want to know my total balance of private tokens, and I have, n number of these records. So I just, find each one of these, find the balance in each of these records, add up the total, and that's my total balance. The way we use these records is the idea of transition functions. So transitions will consume records and optionally produce new records. So once you spend a record A here, you put it into this transition and it gets spent. This cannot be used anymore. So if you only want to use part of the value, you'll end up needing to produce this new record that with the amount deducted. I'll give you a concrete example here. So let's say we have this token transfer function on chain. Alice owns this record with a balance of 10. This is on chain. It's going to be encrypted. So it's going to be this ciphertext I showed you earlier. And Alice says, I want to transfer to Bob 3 units of value. She'll call this transition function with these inputs. It'll produce this proof pi, this zero knowledge proof that says everything here was done, so that people can verify that this was an honest computation without actually seeing, for example, who Alice was or what the data in this record was. It'll have the proof, and then it will output 2 new records, because this original record is now marked as spent. One new record will be for Bob, obviously having his 3 units of value, but obviously Alice needs to get her 7 units of change back. So you'll need to produce a second record for Alice again that has the deducted or the remaining amount. So yeah, that's the idea of private state on Aleo. It's these individual units, kind of UTXO. We also have this idea of public state. So very traditional, like you can think of like mappings in Solidity or any kind of on-chain storage. We also have this idea of mappings, and that these are fully public, but they obviously have a lot of use case for certain things like DeFi or just general storage where you don't really necessarily need information to be private. So in Leo, how do you kind of approach updating and managing public versus private state? So I told you earlier that the transition functions where how you modify private state. sometimes you'll want to modify private state, but additionally have some kind of on-chain linkage where you update the public state as well. And in that case, you can prefix your transition with this idea called async. And essentially all that does is the async transition runs off-chain, and it signifies that, hey, by the way, there's a second part that needs to be run on-chain at a later time once I've done my execution off-chain, sent the proof, and all the necessary information. So again, async transition, off-chain computation with this proof of execution, and potentially selective disclosure of the inputs depending on how the developer implements them. I mentioned this idea earlier of the future. This is where it comes into play. So these async transitions, at bare minimum, must return this future, which is again signifying a call to this on-chain code. Then we have this idea called async functions, which is the corresponding on-chain computation. All inputs here are public necessarily because it's run on chain, so you have to be able to have plain text information. And you can't just have these stand alone. They have to be called by an async transition. So they have to kind of be linked to a particular off-chain computation. This is kind of a helpful diagram to visualize that. So off-chain is this async transition, which is linked to its counterpart on-chain of this async function. What this looks like, again, in Leo code is, again, you have async transition foo, and we say it's going to return a future, and then we return a particular call to a function, in this case bar, and we see below that bar is this async function, which is the on-chain code that'll run later. So, taking a step back and giving you the full picture, the data types available in Leo, we have 16 primitive data types. Most of them you'll probably be familiar with. Boolean, signed and unsigned integers of varying size, address, just an Aleo address, signature is part of a signature scheme that we use. And the three on the left may be where you're not as familiar. So field, scalar, and group, these are kind of advanced concepts in elliptic curve cryptography. And for the purposes of this kind of high-level intro, they're kind of they're essentially numbers with very unique properties. Field is kind of the most basic. It's essentially a number between 0 and I believe it's like the maximum of 384-bit integer. Yeah, and then there's kind of just these unique properties and functions we can take advantage of, especially considering we have this fundamental ZK circuit layer underneath. I definitely encourage you to look into our docs and ask questions. There's a lot of really cool things you can end up doing with these. We also support this idea of composite types. So again, I mentioned earlier the records, but we also you can define just these arbitrary structures. So we mark it as struct, and in this case, it's call it message, and then you can have any number of fields inside. So a timestamp, which is U64. You can have this data, which is an array of 10 U8 integers. We do support array types, and then some signatures. So again, just for organizational purposes and really to make this a more robust language. So this is what I was mentioning earlier, public and private variables. At the top here, this foo is just this kind of helper function for computing the difference between two integers. But you can see in transition main here, we've marked the first variable x as public. So when this computation gets run and the proof and everything gets put on chain, x will be revealed in plain text. You'll be able to see exactly what that number is. If you look at the output, you'll see private U64. So when transition main gets run again, put on chain, the output will be encrypted in ciphertext. You'll see y is actually not marked with anything, and that's because by default, if you don't specify, it gets marked as private. So we believe in privacy by default. And only you as the developer can explicitly choose to reveal certain information. Again, just additional kind of basic concepts like conditional, so if else, and loops, so for I in this particular range. I will say that we do not have while loops, and there are some kind of quirks and tricky things with loops. In particular, we can't really have unbounded loops because of the kind of fundamental ZK restrictions with circuits needing to be kind of fixed size. So that's kind of those are things you'll learn as you take this journey through building on Aleo and the Leo language. And we'd really appreciate that if while you're building this, if you have any feedback or requests or things you think should be different, please pass it on. And we're always looking to kind of improve the language. So let's talk a little bit about tooling and what's available to you to start building on Leo. So first thing, we have this online kind of execution tool. It's called the Leo Playground. If you want to start building, and without the hassle of installation, you can go to play.leo-lang.org. So here we'll bring it up on the screen. Yeah, so this is kind of our thing. It's meant to be kind of very similar to the VS Code interface. When you load it up, it will automatically kind of spin up this auction default program example. We have a bunch of other program examples on there, so you can start to take a look at the code and get references. It will have all the appropriate files built or included. You can do Git integrations, create your accounts, scan for certain things, execute on-chain programs, so on and so forth, and deploy. Just very designed to really help guide this journey and help you bootstrap with the Leo language. A lot of you probably are going to be eventually going to get more advanced than that. And you probably are going to want to use the classic code editors. So we do also have extensions for all the major editors. So VS Code and all the derivatives like Cursor, JetBrains, Sublime Text. We do offer support in all of those editors, and check out the docs to learn how to install all that. So the next thing is the block explorer. That's obviously kind of a critical feature of how you're going to navigate and see your transactions on chain. So this is our block explorer. It's at explorer.provable.com. It has a ton of information about everything you can ever want to know on chain. What kind of programs are deployed, what's the call rate, the blocks, obviously, what's included in those blocks, particular transactions, again, with breakdown of public inputs, private inputs, and kind of a robust set of information. We also have a wide set of software development kits. So first one is obviously we have a lower level JavaScript TypeScript SDK. So if you want to access a lot of the core functions without needing to deal with any kind of wallet or browser extensions, core Aleo functions like program execution and loading and querying the chain, we have an Aleo SDK for JavaScript TypeScript. We also have wallet adapters, which I mentioned earlier in the Shield wallet section. And this kind of wallet adapter will be able to link up with any of the major wallets on Aleo. I'll give you an example of that here. In our we also have a testnet faucet. If you're, as a developer, you're obviously going to need, eventually want to deploy to testnet, you're going to need some testnet credits. So you can head over to our faucet, which is here. and get a certain number of credits. And obviously you can see up here we have this connect wallet button, and you can see all of the wallet providers. This tool is also will be made available to you. So here I'm gonna kind of give you a fire hose of a bunch of resources that I showed you and more of the docs. Don't feel the need to just copy this down. We'll be sending out an onboarding document with all the information I discussed in this presentation and more, just to help you get started. So the playground, the faucet, both our sets of docs, the blockchain explorer. We also have, this is kind of our community venue. So our main source for community on Aleo is our Discord. We have a kind of a nice bunch of different community forums, and including a dedicated section for dev support, where you can come ask technical questions and get help from myself, our other DevRel engineers, as well as longtime community builders are pretty active in there. We also have our Aleo Devs Telegram. That's our, again, our Telegram channel for the same idea. And then the AKINDO folks also have their Buildathon Telegram channel. So let's talk about, sorry, Helam, hello.
Oh, hello. Sorry for joining a little bit late because there was some network issue. Sorry. Go ahead, please.
Yeah, so let's get into the details of the Buildathon specifically. So for those not familiar, a Buildathon is this idea of a long-term development competition where you have this wave structure where you build your project, you submit it, there's a judging period, you get some feedback, and then you're encouraged, there's multiple waves, so you're encouraged to keep iterating on that feedback and keep building out this this project. And it encourages this kind of continuous development versus something I'm sure we've all done with these weekend hackathons. As you spend all this time building it, you get judged, you maybe get a reward, and then you just quickly abandon this hobby project. The one thing I think most people here will care about is the total reward pool for this Buildathon is 50,000 USDT, obviously split out over all the different waves, but it's certainly a great incentive for a lot of people to join in. And the theme, as mentioned at the top, is build a privacy-focused application on Aleo. So what's the timeline for this? We're going to have 10 waves, where each wave follows this 14-day build cycle. So the first 10 days will be the build phase, where you obviously work on your features and ship new things. And the final 4 days is the judging period, where judges that, like myself and the rest of the Aleo team, will review and score the projects. And the total amount available per wave is 5,000 USDT, obviously 50,000 total, 10 waves, 5,000 per wave. The program duration will run for 6 months, so from January 20th through June 9th. And January 20th obviously being 1 week from today. So, kind of give you a sneak preview of the judging criteria. What we're looking for is products, not projects. So we just don't want like something you can throw together and be like, oh, this is a cool proof of concept, but I don't really actually have any data to back it up. We're looking for, okay, there's a clear thought put towards this idea of product market fit, where this will go, clear vision of here's where here's my idea, here's where this project is now, and here's where I think it can take it, and maybe some validation backing up that thesis or that thinking. So there will obviously be given a lot of weight and bonus towards projects who provide that kind of info. But in terms of the pure evaluation of a project, this is kind of the breakdown of the weights. So 40% of the judging will be on privacy usage, because the whole point of this whole focus of our brand and everything we do is privacy. So does your project take advantage of our privacy preserving capabilities? It's very easy to imagine that you could take something like a simple DEX from Ethereum and port it over to Aleo and just not use any of the privacy features, just keep everything public like every other chain. But that's obviously not kind of in the spirit of the build-a-thon. The next 20% is purely technical implementation. How well engineered is your product? Did you focus on speed? Did you focus on kind of code cleanliness and readability? Did you do a lot of robust testing and hammer on any bugs, etc.? Next 20% is user experience. So the forward-facing aspect, like if you were a user or I was a user and I just went to go use your product, how much trouble would I have to take advantage of everything, and how much trouble would I have understanding how powerful your product is? And then there's an additional 10% for just purely practicality. Is this just kind of a pie in the sky idea, or is there real vision where this could be used? And then additional 10% for novelty and creativity, either in regards to our ecosystem. So maybe you could take an idea that's maybe been done before, but just is pretty impactful and hasn't been ported to the Aleo ecosystem, or maybe you just come up with something that's never been done with privacy in general. So that's the breakdown of the criteria. We're happy to answer any questions, and you'll obviously get a lot of feedback as the competition rolls on. Last thing I'll say is there is an event at ETH Denver. So Hila, maybe you can speak more to this about how this is relevant to our build-a-thon. Oh, you're muted.
Sorry.
Go ahead. You're fine now.
Yeah, thank you so much, Alex. That was really helpful. And yeah, as Alex talked, like we are going to have a demo day at ETH Denver coming in February, and the selected like nice product will be on the stage, and then VC can also see your product. So I think it will be a really great exposure opportunity. So please follow the Buildathon stage, all the waves, and like it will be a really great opportunity for you guys.
Yeah, awesome. Thank you, Elam. Yeah, so again, just to hammer home, like this isn't the idea, the spirit behind this competition isn't just to, again, throw together some project and then abandon it later. Like there's real opportunity here to build a really great product and then get it in front of investors and VCs and people who want to support that project and hopefully make it a huge success. Yeah, so on that, let's kind of move to the Q&A section. So any questions you guys might have or feedback, please feel free to speak up now.
Yeah, thank you so much, Alex. That was really helpful. So we'll now move into a short Q&A session. So if you have any questions, please drop them into the YouTube live chat, please. So I'll go through the chat and ask a few questions on your behalf. Okay, so one question is, so what is the main purpose of the Buildathon like for Aleo side, like attract devs or users or something special?
So the idea is that we are still kind of a very young and fledgling ecosystem, and we have this great technology. We have this very powerful paradigm of privacy in crypto that nobody else has. And now that we're starting to mature, we need really great products built on top, so people, the average user who's not technical can take advantage of all this great privacy features. And we have a great development team, but obviously there's a ton of work to be done. So we always want people to come and build on Aleo, and we're looking for this kind of next killer app, the next Poly market to take advantage of privacy and to be built on Aleo.
Okay, thank you so much explaining. So the second question can be the one like, could you please share some popular projects in the Aleo ecosystem currently?
Yeah, so a lot of the projects that have been built, thus far have been a lot of tooling and kind of fundamental um, things to help make the ecosystem more approachable. So again, we have our Provable Explorer, but we also have had community members build their own explorers and their own indexers to track the chain. We obviously we have the stablecoin products that are coming. We have again starting. We had a bunch of wallets being built. But in terms of like really interesting previous hackathon projects that have been built, we had kind of an escrow service that was built. So it's called a ZK escrow, basically a way for you to take crypto funds and store it in escrow without necessarily revealing the amount or needing to reveal like who was involved in putting those in escrow. We've had identity solutions that have proof of concepts have been built out. So like verifying biometric data like a passport and kind of creating this on-chain credential and privately verifying it without obviously revealing your passport data. So just interesting kind of things that have been ideated, but we are again obviously looking for the next kind of really killer app.
Okay, thank you so much. I think like the last question could be this one, like apart from the docs, are there like other materials to further understand Aleo?
Yeah, so I will say that we have done workshops in the past, but I'm actually planning on um this kind of kickoff was more of a high level overview of Leo, but I am planning to do um kind of more in depth and specific workshops. So like for example, a walkthrough workshop on how to build a token, a very basic token, and how to engage in certain DeFi primitives and things like that. So we'll be doing workshops and producing content um, in the coming weeks and basically moving through the build-a-thon to help people get a better understanding of what's possible.
Okay, thank you so much. I think like one more question. I think there are so many questions right now. So the Kufru Abasi Base says like, are we restricted to just building dApps, or can we just use the ZK proofing to improve our existing Web2 app to make it more private?
Yeah, so I think that the kind of spirit of the competition is to take advantage of the Aleo network in its entirety. So we're really kind of looking for um, dApps in my mind, but um, yeah, it really depends on the idea. So if you think that you have kind of a killer app that can take advantage of that, we're happy to give you feedback and kind of help you build on that idea.
Okay, thank you so much. So I think like there were some people who's wondering about like AKINDO waves. So I think like I can briefly share my screen and show our website.
Yep, definitely.
Can I share my screen? Okay, thank you. Mm, Okay, so as you can see, this is like our AKINDO webpage. You can just like simply come and join this webpage. So this is like a Aleo Buildathon. So oh, already so many builders joined here, as you can see. Also, if you have like any questions, like you can simply join our uh, Telegram group. So you can always like ask questions and you can get the answer from there. So please like join the Telegram group from this community button. And, okay, so this is the wave. Like the wave is like you can just simply think it's like a stage of the long-term hackathon. So each wave has like this duration and also like judging period, and then after that there is an allocation as you can check. Okay. Okay. So this is like I think like Alex already explained very well. So I will just skip this part. So if you have any question, like you can always just like join our Telegram group or Discord. So ask like any question from there. So I think that's it. Okay.
Yeah, please join whatever channel you see you'd like to, and whatever you think is best for your needs. And then myself and a lot of our DevRel team are present in all of them, so we're happy to answer any questions you might have or any technical support you might need. That's what we're here for.
Yeah. Yeah, I think like that's all for today's onboarding session. So thank you again, Alex and the Aleo team, and thank you to everyone who joined us live. So if you haven't signed up yet, please just make sure to check out the Buildathon page and get started. So we are really excited to see what you build, and we'll see you in the next session. So thanks everyone.
Thank you,
Thank you,
everyone.
Alex.
Appreciate it.
Bye bye.